question 1, methane gas reacts with chlorine gas to form dichloromethane and hydrogen chloride, as represented by the equation, which is CH4 plus 2 chlorine gas turns into CH2Cl2 plus 2 HCl. Our given is 25 grams of methane gas and 2.58 moles of chlorine gas. Part I of 1 asks us to identify the limiting reactant. We are given both CH4, the methane, and chlorine gas. So all we have to do is solve. So you use stoichiometry. 25 grams of methane gas. There's 16 grams in 1 mole, and then it's a 1 to 1 ratio. So you get 1.56 moles of CH2Cl2. For chlorine, we are given the moles, which is just taking away a step. So 2.58 moles of chlorine gas. There's 2 moles of chlorine gas that turns into 1 mole of CH2Cl2. That gives us 1.29 moles of CH2Cl2. So since the chlorine gas gave us less, then the chlorine gas is our limiting reactant. In part 2 of question 1, we are asked to calculate the total number of moles of CH2Cl2 that we can get with the limiting reactant. We've already done this in part 1, and we'll just do it again for the sake of the problem. We are given 2.58 moles of Cl2, and there's 2 moles of Cl2 that react into 1 mole of CH2Cl2. That'll give us 1.29 moles of CH2Cl2. Question 2 gives us the equation that iron reacts with oxygen to produce iron 3 oxide, as represented in the equation above, which we will balance later on. A 75 gram sample of iron is mixed with 11.5 liters of oxygen gas and at 266 atm and 298 K. Part A asks us to calculate the moles of each of the elements, Fe and oxygen gas. So for the iron, they give us 75 grams, and we just convert it to moles, and that'll give us 1.34 moles of iron. For part 2, we have to use PV equals nRT, the ideal gas law. We just plug in the pressure, the volume. We need to find the moles, the constant, and this. And then when we multiply them all together, we get 30.59 equals 24.5 N. And then we just divide out 24.5, and that'll give us N equals 1.25 moles of oxygen gas. For part B of question 2, we have to first balance the chemical equation, and we have to have 2 Fe because it's written in, and we can't change that. So to balance it, we have to make O2 3/2, which isn't a whole number, obviously. That'll translate to 1.5. So we have 1.25 moles of O2, that's our given. Or no, that's what we found in part A. And 1.5 moles of O2 translates to 1 mole of Fe2O3. And that'll give us 0.833 moles of Fe2O3. The next part's normal. We just have 1.34 moles of Fe. 2 moles of Fe turns into 1 mole of Fe2O3, and that turns into 0.67 moles of Fe2O3. And obviously the limiting reactant, since we get less from the Fe reaction, 1.34 moles of Fe is our limiting reactant.